Okay, so we'll do some basic visualization. Okay, so to visualization. Okay, now you need to import matplotlib, right? Okay, so the base, okay, the basic library of any data visualization is matplotlib. So you have import matplotlib dot pyplot as plt. Okay, and so what I'll do is I will generate some random number, okay, using NumPy, and you will use that to plot a histogram to it. Okay, so see, from machine learning perspective, your histogram, box plot, okay, it is frequency distribution. Frequency distribution is similar to histogram. Okay, so then your scatter plot, okay, these are important. Okay, you'll have to do these things. Okay, correlation and things like that to understand. Okay, so we'll learn histogram. Okay, so I'm going to say I'm going to generate some random number. Okay, so I'm going to say here data equal to np dot random dot. Okay, so random number, okay, rand n, okay, and I'm going to say generate 1,500, 5,000, okay, you can say as many numbers you want. So it will generate 1,000 numbers for us. Now we will use to plot histogram. So plt dot hist, okay, plt dot hist, and you put data here. Okay, that's it. Okay, now you'll say plt dot show. Okay, now when is the plt dot show, and now when you run it, p1, you will get histogram. Now what is histogram? Do you know what is histogram? Histogram, okay, is so when we say rand n, n is for normal numbers. Okay, so if you say normal numbers, the values will be mostly between 99.95% values will be between -3 and +3. Okay, so rand n will generate random numbers. Okay, that within 3 standard deviation, and this is random numbers, obviously, right? So what it has done, it has created, so your histogram will group them. If you remember, we have done histogram where we have taken the numbers and you group them. I told you histogram should have same, like you decide how many buckets you want or how many bars you want. Okay, so if you want 12 bars, the size of each bar should be same. Okay, so for example, if you have value that ranges from 0 to 100, okay, so now if you decide to have 10 bars, okay, then each bar size should be like 10. So 0 to 10, 10 to 20, 20 to 30, like that. If you have 0 to 200 numbers, the spread is between 0 to 200, and you want to keep 10 bars, 10 bins, right? 10 number of bars. Then you'll have values from 0 to 200, 20, 20 to 40, right? So you need to decide how many bars and what should be the size. So in this case, we have not told anything, right? We have not said anything about bins and size. So Python will automatically, okay, take the values and will plot it. But if you want to indicate, okay, that no, I want a specific number of bins. Okay, so you can draw. So here I can add like data. Then I can say here bins. Okay, so bins equal to 30. Now, when I say bins equal to 30, okay, it will automatically look at the minimum and maximum value and it will divide. So if your value is between, with say -3 and +3, okay, let's say your value is between -3 and +3. So -3 plus 3 is 6 numbers, right? It will divide by 30. So it will have maybe, 0.2 difference of, is it 0.2 or 0.4? Whatever, it will calculate and it will create bars of that number, okay? You can even say his type, what type of histogram you want. So if I say step filled, it will, so you have something called as step filled. So it will step fill the bar, the bars of the histogram. So, okay, you can, so now you see here, it has come. Okay, so it has taken 30 size of, divided into 30. So you'll have 30 bar graphs. Okay, so this is how you can plot a histogram. If you want, you can give size. Okay, sorry, the header. You can even give the size of the bar. Okay, color. Okay, so let's say I'll give color here. Color as blue anyway we saw, right? We'll put red. Then you can even give the header. So I'll say plt dot title. Title will give it header. So I'm going to say histogram display or something, whatever. Then you say plt dot x label. Okay. So x label on x-axis, what do you want to display? On y-axis? So let's say on x-axis, I'll say marks. Okay. On y-axis, plt dot y label, I will say number of students. Okay. Okay. So you can then run it. You see, this is the graph you are getting. So it has filled with red. Okay, you have an outlier. Anything more than 4 is outlier. So you see there's outlier value also. It can get outlier as well. Okay. So this is how you can generate histogram. You have see X label, you have Y label, you have title. Okay. Now, what I'm going to do is I'm going to take, okay, one example. Okay. I'll take one example and I'll show you, okay, how generally we perform analysis. Okay. So there is a data set here. Okay. If I go back to sure. If you go back to my GitHub link, data set, go to the data set. Okay, there is something called as hotel data, HGH, hotel booking. Okay, hotel bookings. Okay, and we are going to use this. Can we read it? Yeah, you can read it. Okay, so see here, it has ID, hotel, is cancelled. Okay, so is cancelled. All is question mark will be either true or false. You'll have 0 or 1 or true, false. Okay, is cancelled 1 means cancelled. Is cancelled 0 means not cancelled, false. So you have column here. ID, hotel is cancelled, lead time, arrival date, year, arrival date, month, arrival date, week, arrival date, day of the month, stays in weekend nights, stays in weeknights. Okay, so this is the data set. And we will use this data set to perform our data visualization. Okay, so let's start. Okay, so first we will, first, of course, we will read this link, right? So I don't know, system got hanged again. So I'll keep this here. I'll move here. So I'm saying analyzing hotel bookings data. Location. Okay. This is the raw location. Okay, this is the link equal to this. And actual location of the data is this. Okay. So I'm going to import pandas as PD. Now I'm going to say, let's use df equal to PD dot read CSV, and I'm going to give this link. Okay. Now we'll do some basic analysis of the data. Okay, you want to see the shape, how many rows and columns are there, shape of the data. You can say df dot shape. You want to see the different data types, you can say data types of the columns, and you can say here df dot d types. Okay. Still running the old file. We need to change the file. Okay, it's going to read, it has more than 1 lakh rows. Okay, so you can say this here. 1,19,390 rows and 33 columns. Okay. And these are your data types of each column. So you have ID, which is integer. You have hotel, which is object. That was string, right? Hotel name. Then you have is cancelled, yes or no, lead time, okay, arrival date, year, integer, arrival date, month, object, month will be Jan, Feb, September, October, like that. Week number, float. Okay, so you can actually see each data type here. Okay. You want to filter that out. Okay, so I'm going to say df numeric. You want to filter it. Okay, so you can say df dot select d types. Select d types, and you say include. If I want non-numeric, I will say exclude. Okay, so include, and include what data type? Okay, so I'll use import numpy as np, and I'll say here np dot number. Okay. Okay. Okay, so this should give us only the, okay, all the data which is data frame, okay, all the data frame which is numeric. So if I print here df numeric, okay, I'm going to comment this. Okay, we don't want it to give us the previous output. Now you see, this has filtered the data. Okay, now you see only 21 columns have been filtered. Okay, because rest of the 11 columns are non-numeric. Okay, if you want to see non-numeric, okay, you can copy the same stuff and we will change it to df non-numeric. and I will say exclude here. Okay. Now, if you want to see non-numeric, you should see 11 columns here. Right? If out of 33, if 21 are, no, 10 only, right? Not even 33, right? That's wrong. 21 is numeric, so 33 minus 21, 12, right? So 12 are your, so this will include your string as well as dates, right? Anything non-numeric. So dates are also non-numeric. So these are the columns for non-numeric. Now, if you want to see the column names, just the column names. So you'll say numeric columns equal to df numeric, okay, dot columns dot values. Okay, so I'll comment this print, okay, comment the print, and I'll say numeric column names, okay, and here you say your numeric columns. Okay, similarly, df non-numeric, right? Non-numeric columns. So non-numeric columns is this. So this I'll put non-numeric. Okay. So see, these are your 21 numeric columns. ID is cancel date, time, arrival date, year, etc. And these are your non-numeric columns, 12 non-numeric columns. Hotel, travel date, month, meal, country, market segment, etc. Okay. Now let's start our visualization. So first step that we are dealing with, okay, so we call this as pre-processing the data. Before you perform any analysis, right, you need to make sure if data is in correct format or not, right? So first thing that we generally check is if data is missing or not, right? So the concept of checking missing data is very similar to what we did in machine learning sklearn, but of course, here we are not going to use sklearn, right? So we'll see how we can do using pandas. So I'm going to use another library called Seaborn. Okay, Seaborn is advanced library of using for doing plotting. Okay, but it is also based on matplotlib. So we will have to use matplotlib. No matter which library you use for visualization in Python, you have to use, okay, matplotlib. So import Seaborn as SNS, import matplotlib as, okay. Now, we will draw a heat map. What is a heat map? So I'll show you a sample of heat map. We talk about heat map, okay. Okay, it shows different color for different areas. Okay. Now, if you have to look at, let's see, let one example come up on our screen. Okay, so if you take, this is US map, and this talks about temperature. Okay, so see, here you have colors. Colors will change based on the value. So, okay, if you see here, color is changing from maybe from 0 to 60 maybe, right? So it says 0 is like your whitish pink, and then it becomes dark pink, then it becomes blue, then light blue, green, yellow, red, and then, something like your dark red, okay, maroon or dark red. So that indicates that it is very high temperature. So by looking at the color, okay, by looking at the color in the map, you know which areas are cooler, which areas are hotter, right? Same thing we are trying to do with this. So in our case, okay, missing value, okay, we will have just 0 and 1. Okay, so in our case, we have here you have multiple cases, right? Obviously, you have many cases here, but we will use heat map in our case also to see where data is missing, where data is not missing. So we will use 1 for missing and 0 for data which is not where it is not missing, right? So just 2 options in our case. So let's do that. Okay, so obviously to do that we need to um, create some kind of color map. Okay, so let's go back to our program. Okay, I'm going to use the hexadecimal color. Okay, so let's say I put colors or colors equal to so 0 will have this color, 1 will have this color. Okay, which color you want for 0? So again, we'll go back to Chrome here, and I'm going to show you hexadecimal color codes. Okay, hexadecimal color codes. Now, if you look at hexadecimal color codes, okay, each color will have a hexadecimal. Hexadecimal will have, see, so each color is made up of 3 colors, right? 3 primary colors. RGB, red, green, and blue, right? So you use different percentage of each color, you get a different shade. So if I need a blue color only, then I will have red 0, green 0, and then blue will be 255. So maximum value it can take is 255. Okay. So you decide which color you want. So that is a number. Now you have to convert that into hexadecimal. So hexadecimal, if you see, the value ranges from 0 to 16 digits. So up to 9 is 10. Then you have A, B, C, D, E, F, right? So hexadecimal will go up to F. So 0 to F is our digits for hexadecimal. And 2 places are reserved for, okay, each color. So 03 means sorry, I think connection lost for a few seconds. Now you're back, right? You can hear me, right?
Yeah.
Okay. So here, okay, I'm going to select this shade here. Okay, so this shade is hexadecimal color is this one. So I will copy this and I will move on to I am not able to share. Yeah. So this is the 0 thing. Okay, so I'm going to use is null. Is null true? So is null true is going to be 1, right? If it is empty, it's going to be 1. So let's put 0 as red. So I'll move this to 1 because I'm going to check later if it is null, then. So if it is null, 1 means true. Null is true. So null will have this value. And for the other one, I'm going to select some kind of blue shade, let's say. So I'll just copy some blue shade and I'm going to paste it blue shade at position 0 here. Okay, so I'm getting ready for the colors that I want to plot on the graph. Okay. Now I'm going to plot the graph. Okay, you have SNS dot heat map. So last time we used matplotlib.hist. Okay, for using matplotlib histogram, I'm using SNS Seaborn heat map. So I'm going to say Seaborn heat map, and here you define all the columns that you want to display. Okay, so I'm going to say df columns, and then I'm going to say is null. What is columns? We have not defined the value of columns. So I'm going to define calls equal to df dot columns. Okay, so df dot column, so it's going to be df calls is column, and I'm going to say if it is null, okay, then C map, okay, color map equal to SNS. SNS has color palette. Okay, here you mention the colors. Okay, so I'm going to mention the colors here. Okay, now I'm going to say plt dot show. Okay, now let's run this and see what happens. So mind you, there are 33 columns. Okay. So now look at this graph. We said, okay, we said blue is for, okay, 0 is null 0, right? So blue indicates that these, okay, they have the value. And red indicates the values are missing in that column. So see, each of these are columns here on x-axis. And these are your rows reference from 0 to 1,19,000 here somewhere, last. So the blue means these columns have the values. The red here, we don't have the value here. So there's one column here, which looks like almost like 95, 96% values are empty. Here also some values are empty. This also has some values empty here. This have some values empty here, right? So now what should be our strategy? Okay, if they're all blue, we would have happily gone to the next step. But we don't have all blue here. We have some missing values. Then how do we handle missing values? The same logic, okay? If you have very large missing values, if you have very large missing values like 80% values in a row or column, we'll delete it. I don't see any row has more than 80% here, right? Okay, only columns seems to have values missing here. So if your data set has large values in the columns, okay, we'll delete that column. Not required, right? I mean, it's not, I mean, delete in the sense we will ignore it for our visualization. Okay, it's not contributing much. Okay, we don't know the name. We'll see later. We'll use a for loop to go through and count the number of missing columns here. This column definitely has no contribution. We can delete it. Okay. Now, so there's here you see there's some values here. Only few values are missing. So out of 1 lakh, if 5,000, 10,000 are missing, okay, it's very less missing. But if 17,000 are missing, then it's very large, right? So we could ignore, all right? So we will see how to ignore that particular column, and then later we will see how to work with other columns to, handle this missing value. So so there are two ways that we do. Okay, one, as we discussed in machine learning, that we replace it with mean value, right, or median value for numeric. Non-numeric we'll replace with mode, right, maximum occurring values. So we will do that. You can also replace with some specific values, say NA or minus 99 to indicate that those values are missing values. So it's up to you based on your requirement what you can do. You can replace with specific value to indicate those, those are missing values, or you replace with mean to make sure that they don't contribute much on the analysis kind of thing. Okay. Okay. So let's get down to business. I can also use for loop and calculate the number of missing value in each column. So we'll iterate through each column here. So I'm going to say for column in columns, okay, we have columns here, right? Which has all the columns. We'll iterate through these columns and we will see which columns have missing values. So I'm going to calculate percentage missing. Okay, so percentage missing is, anyway, we have numpy dot mean. It will calculate the mean value of df of coal. So we're taking each column and we are calculating is null. Okay, so we're taking each column and we are calculating is null here, right? And what will mean give us? Mean will add them together, okay, and divide by the total number, right? That's what mean formula is. Okay, so if you want to look at percentage, we have to multiply this with 100. So if there are 10, let's say 10,000 values in that particular column. So it is about each column, right? Going through each column. So if each column, let's say one column has 10,000 missing values in that column. So average will give you 10,000 by total, which is 1 lakh, right? 1,19,000. And if you multiply by 100, you get percentage. Now we can see the okay, how many each of the columns have missing values here, right? So I'll comment this all the print here, right? So that we don't get distracted by the output. And here then I'm going to say print, okay, F formatting, and I'm going to say column name, right? So column name, and then I will say, okay, your percentage missing. Okay, let's run it and see. You see this? So ID hotel, no missing value. Okay, this has missing value. This has no missing value. So this has like 0.0083. I mean 0083 percentage. Okay. Okay. Very less. Okay. 13%. See this company. So probably the one that had all red one, right? That's company. 94% is missing. Okay. So we can delete it. We can delete it. Okay. So this is what we're going to do. We're going to delete. Okay, we'll put some like percentage as like 80%. Okay, and we will see how many are more than 80%, and that column we will delete it. Okay, so here, okay, instead of printing all, I can say here if percentage missing greater than 80. So we can see how many columns have percentage value missing more than 80%. It will take some time. So see, only column company has more than, okay, missing. So what we'll do, okay, so we will remove column since it has more than 80% missing one. You can decide your own threshold, okay? We have said 80%. So we're going to drop it. So I'm going to say here, columns. Okay, you can actually, you know what, you can build a columns here. The columns to drop, okay, equal to blank list. And here you print, and as well what we'll do, we will say columns to drop dot append, and we'll put column. Okay, so that means we are building this column list to drop, right? And then we will say here df equal to df dot drop. Drop is to remove. Drop what? Columns to drop. So this is the the list that has all the columns to drop, and we have to indicate whether you are dropping row or column, right? So axis 0 is for rows and axis 1 is for column. So I'm going to say drop this list of columns here. Okay. Now you draw, we'll call this again. Okay. Okay. Now let's see. We can comment this, right? We don't want to print it again. So let's comment this. So this is the way to drop column. Now we need to calculate how many missing values are there in a row. Okay. So let it come. Meanwhile, now we have to check for rows. Okay. So what strategy will apply is we'll go through each row. What happened? Key error. Company is this. Okay, so company got printed, and columns to drop. What's the problem? Key error, another following exception. This is creating problem? Let's see this. And we will see why this is creating problem later. Oh, see, column in columns, right? So the column is here, original column, right? So this will not, the company name is not dropped from here. So we need to calculate it again. Or better still, okay, instead of using columns, we can directly use column. So it will take the latest values. Okay, you can delete column. So company got deleted, right? But still it is trying to go and calculate through column, and that column company column is not there at all. That's how we got an exception. Okay, so print did not print anything here. Print did not print anything. That means there are no columns more than 80%. So this got deleted. Okay. Now we will look at the rows. Now, how do we look at the rows? So for rows, we will calculate, we'll go through each row and we'll calculate how many columns and how many rows are missing. Okay. So what we will do here, okay, we'll perform this loop in loop only. Okay. I'm going to say, okay, okay. So here, let's say, okay, um, okay. So this is to check column, right? Now we will check rows here. So I'll put this here itself. Now I'm going to create a something called missing. Okay. Now this missing we'll talk about df uh, column, okay, which have missing values in a row. Okay, so is null. Okay, so if it is null, then of course your number of, okay, number of missing. Here I'm taking average of missing. Here I'm talking about number of missing. Okay, so number of missing will be np dot sum. Okay, mean gave us missing. This will give us sum. So this will give us sum. Okay, so now we know how many values are missing here, and if the number of missing value is more than 0, that means if there is a value here, then we will create a new column. Okay, so if let's say if hotel has a missing value, we'll create one new column called hotel missing, and there we will, okay, we will add total number of missing values. Okay, so so now missing, and if num missing, okay, is greater than 0, then I'm going to say df, okay, df, and here I'm going to use the column name. Okay, so df column underscore missing. Okay, and this will have number of you're missing. So missing is the variable there. Missing. Okay, I just want to have some print statement here saying that we just created, we got a missing indicator. Okay, to tell that there is missing for column. Okay, so you say F here. Okay, so let it run. Meanwhile, what we'll do is outside this loop, once we know we have created this column, now we will go and see the missing count, right? We need to know the missing count. Okay. So okay, so these are the columns for which we created. These are the columns, they have at least one value missing, at least one, greater than 0, right? At least one missing. So now, okay, I'm going to say is missing column. Okay, keeping track of the missing values. Okay, so is missing columns. Okay, so I'm looking only at the missing columns now. Okay, not all the columns. So is missing column, okay, we'll go through for call in df dot columns, each columns, if, okay, you have is missing. Okay, so I'll put is missing here, something like that. Okay, so I'm going to check the column names. Are we talking about these columns? We are only interested in is missing columns. Okay, if is missing in call. Okay, and these columns only we will take as a list. Okay, only these columns we will take as a list. Okay, now you say df number of missing column equal to df okay dot count dot sum will sum all the values here along the column axis. Okay, so this, if you plot print df missing, so this column will have number of missing values for each row, right? We are calculating, okay, for column and putting it here, right? So this will, when you print this, you'll have 0, 1, 10, 1,000, 500, something like that to indicate how many values are missing. Okay, so say this has first column has 1, 1, 1 missing, 0, right? Now we will do something. So we have 33 columns, right? So out of 33 columns, you can decide, okay, how many columns you know, how many rows, sorry. So, okay, so these are number of missing values in each row, okay. How many missing values can you tolerate? Okay, so I can't tolerate, let's say, more than 12, okay. Okay, it's up to you, okay. Again, you decide how many should be. So to drop the rows, how many data should you have missing values? So I'm going to put something like, say, 12 or 15 or 20 or 25, okay. So we are dropping the rows now. We drop the columns, we drop the row which will have, let's say, more than 12 missing values. Okay, so we'll drop the row, and tomorrow when we meet, we'll talk about how to replace these values with mean and mode. So drop rows with greater than 12 missing values. So we'll go through, okay, so this is your missing indicator, okay, and this is going to be your df of num missing, right? This is the values that we have identified. Okay, this should be greater than, we are filtering, okay, we are filtering out of df. I need df, we're missing greater than 12, and then I'll go with index value. Index, okay, see, column, we had the column names, we dropped, but in row does not have an row name, right? It has index number. So we need to get access to the index number. This will give us access to the index number. And now I'm going to say df equal to df dot drop, right? Now, since we're dropping rows, we have to say access equal to 0. But which rows are we deleting? All these missing rows. Okay. And now what we will do is we will copy these. Will you know, now we will simply print how many columns have missing values. So I'm dropping rows. Okay, so drop rows dropped. Here we'll say rows dropped. Right? Now count for missing values. Now we will see how many columns still have missing values. So no need to calculate percentage, or if you calculate percentage also, that's okay. We can say percentage greater than 0, right? Okay, if they have anything more than 0, we should get it. Okay, so we are dropping rows with more than 80%, columns with more than 80% blank values. We are dropping rows with more than 12 missing values. Okay, then we'll be left with the rows which have probably, okay, see, again, I should be using df columns, because this is old value, right? So every time, you know, it is looking for the old values. Okay, so these are the columns which we need to handle tomorrow. Okay, so after deleting all those, still we are left with missing values. Okay. So we have about six columns to handle. We'll see it tomorrow. Any questions before we wrap up?